This is Spacetime, Series 25, Episode 104, for broadcast on the 3rd of October 2022. Coming up on Spacetime, NASA's DART spacecraft slams into an asteroid, the asteroid Ryugu tells its story, and confirmation of a new kind of matter. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
NASA's DART, or Double Asteroid Redirection Test spacecraft, has successfully slammed into an asteroid in what's being described as the world's first planetary defense technology demonstration mission.
Looks to me like we're headed straight in. Oh my gosh. Oh, wow.
Yeah. Oh my goodness. 8, 7, 6, 5, 4, 3, 2, 1. Oh my gosh.
Oh, wow.
Awaiting visual confirmation.
All right. Let's see. We got it? Waiting.
And we have impact. A triumph for humanity in the name of planetary defense.
Woo. Fantastic. Oh, fantastic.
The impact, some 11 million kilometres from Earth, saw the 610-kilogram spacecraft hit the 160-metre-wide asteroid at a relative speed of 6.6 kilometres per second, or 22,530 kilometres an hour. The spectacular head-on collision produced a massive debris cloud of ejecta as it hit with the equivalent of 3 tons of TNT. The impact was observed by dozens of telescopes both around the Earth and in space. The target was the asteroid Dimorphos. It orbits a larger 780-metre-wide asteroid called Didymos, and the impact is expected to change the little moonlet's orbit, moving it around 1% or 10 minutes closer to its host asteroid. The 11-month mission has confirmed that NASA can successfully navigate a spacecraft to intentionally collide with an asteroid in order to deflect it, a technique known as kinetic impact. Scientists are now undertaking a campaign to observe Dimorphos using ground-based telescopes in order to confirm that DART's impact did in fact change the little moonlet's orbit around Didymos. The spacecraft's primary science instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO for short, together with a sophisticated guidance, navigation and control system, which works in tandem with the small body maneuvering autonomous real-time navigation algorithms, enable DART to identify and distinguish between the two little asteroids targeting the smaller body. It was these systems which guided the spacecraft through the final 90,000 kilometres of space and directly into Dimorphos, with Draco's final images obtained just seconds to impact, revealing the primitive boulder-strewn surface of Dimorphos in magnificent close-up detail. 15 days before impact, DART deployed the Italian Space Agency's Lycia Cube CubeSat, a small satellite designed to gather images of DART's impact and the resulting cloud of ejected material thrown out by the collision. By examining this plume, scientists can begin to estimate the density of the material on the asteroid's surface. And it doesn't end there. In roughly 4 years from now, the European Space Agency's Hera mission will conduct detailed surveys of both Dimorphos and Didymos, releasing 2 small CubeSats to study both asteroids in detail. They'll also focus on the impact crater and even attempt a landing into the crater. NASA's Planetary Defense Officer Lindley Johnson says DART's success provides a significant addition to the essential toolbox which humans need to develop in order to protect planet Earth from a devastating asteroid impact. Glenn Nagel from NASA's Canberra Deep Space Network Tracking Station says over the coming weeks, scientists will characterize the ejecta produced and precisely measure Dimorphos's orbital change in order to determine how effectively DART deflected the asteroid. The results will help validate and improve scientific computer models, critical to predicting the effectiveness of this technique as a reliable method of asteroid deflection.
So the mission itself is part of a series of planetary protection or planetary defense missions that NASA and other space agencies around the world are involved in. So DART was specifically designed to see what could you do? Could you use a spacecraft as a kinetic impactor to impart enough energy on a small asteroid to change its orbit? In this case, they chose a double asteroid system, Didymos and Dimorphos. Didymos, about 780 metres in size, and Dimorphos, this little moonlet orbiting around Didymos, about 160 metres in greatest diameter. And the idea was to hit this small asteroid, slowing its orbit a little bit around Didymos. And that's what's hoped. We know the impact went off really successfully. It really did literally go off with a bang. The planets, or in this case the asteroids, aligned. So it was all on us with our two of our big antennas, big 70-metre and a 35-metre antenna, ensuring that we could provide that two-way communication, getting the final command into the spacecraft, put it on course for intersecting past Didymos and then straight to Dimorphos, and then of course getting back that incredible stream of images, one per second, coming back in through our control room, straight over to mission control at Johns Hopkins University, and then broadcast to the world. And oh boy, was it spectacular. And now further observations will be done by the Lycia spacecraft from the Italian Space Agency that was there with DART and actually watching the impact directly, and then a whole host of both ground-based and space-based telescopes and cameras observing. Even the James Webb Space Telescope was keeping an eye on this impact. But already we've seen from a number of ground-based telescopes, even ones here in Australia, that actually saw the plume of material, the ejecta, from the impact. And when I saw it, I was quite surprised. It was much larger than I thought it would be.
That's exactly the same thing scientists were saying to the Deep Impact mission to a comet, Tempel 1.
Yeah, and this is something that we're learning about some of the objects out there, especially some of the more recent asteroids that have been visited, like Ryugu with the Hayabusa 2 mission and with Bennu with the NASA's OSIRIS-REx, that seem to be these sort of big loose rubble piles bound together by gravity, just the gravitational forces of these sort of house-sized, building-sized boulders down to little tiny pebbles. And these are the sorts of the early building blocks that over time can become much larger objects, even planets. So in these early stages, they seem to be pretty loose. So the impacts are, think of the equivalent of throwing, say, a golf ball into some soft snow. You're going to actually impact much deeper into it. But in this case, we're getting all this ejecta coming out as well, all of this smaller, looser material.
And that was the other thing that I noticed as well. Boulders on the surface of, I keep wanting to call it Didymoon, Dimorphos. Didymoon was the original name for this satellite orbiting Didymos. The number of boulders on the surface of Dimorphos was absolutely incredible. It's exactly the same as what we saw with Ryugu from Hayabusa 2.
Yeah, so this seems to be a common type of formation of these objects in this sort of 100 metre to 1 kilometre sort of class. Once they start to get probably much larger than that, we're seeing examples where that material has sort of compressed under sort of greater gravity to become more solid objects. But yeah, what was interesting too is the rocks on Dimorphos, or Didymoon, I like that too, were quite angular. So there hasn't been a lot of additional impacts of smaller material to sort of round that off, a version of space weathering, if you like.
And of course, it doesn't end here, as well as the stuff coming back from the Italian Space Agency, Spacecraft, which is now monitoring the situation. In a few years' time, the European Space Agency will launch their Hera mission, which will visit the same asteroid combination to see how things have changed over time, whether this impact has in fact changed the trajectory of Dimorphos and whether it's changed the trajectory of Didymos as well.
Yeah, so it's just an interesting chance to actually go back and see what we have done to this asteroid pair, what changes have happened to something like Dimorphos. Previous missions have done a similar thing. A mission that visited another asteroid by the Deep Impact mission was later that by a second spacecraft that went and had a look at the comet body Tempel 1. So, yeah, we've had a chance to sort of go back and see what have we done to these little worlds out there. But all of this is helping to build up a bigger picture of what is out there. Astronomers seem to say that they only know about maybe 40% of the total population of objects that might be out there. So there's still a lot to learn about these types of worlds, their size, their distributions, the composition, their density. So you've got other missions out there right now, like Lucy, going off to the Trojan asteroids out at Jupiter, the type of asteroid that we've never observed before. So we'll learn about that class as well. So there's a lot more to build up about this picture of our near neighbourhood of the asteroid belt between Mars and Jupiter.
That's Glenn Nagel from NASA's Cabot Deep Space Network tracking station at Tidbinbilla. And this is Space Time. Still to come, the first studies released from the first samples collected and returned to Earth from the asteroid Ryugu, and theorists feel they've now adequately shown that experimental results at the Large Hadron Collider have provided the evidence necessary to confirm the existence of a new form of matter. All that and more still to come on Space Time. The first analysis of samples from the asteroid Ryugu show that its parent body must have been formed in the outer reaches of the solar system, a long way from near-Earth space. The findings, reported in the journal Science, are based on an analysis of 17 individual grains from samples collected by the Japanese Aerospace Exploration Agency's Hayabusa 2 sample return mission to the 900-meter wide space rock Ryugu. The results are providing a fascinating insight into Ryugu's formation history. The Hayabusa 2 launched in December 2014 and rendezvoused with the near-Earth asteroid 162173 Ryugu in June 2018 after a 300 million kilometre journey. The spacecraft studied the asteroid in minute detail for more than a year and a half, deploying several rovers in the process and eventually swooping down to collect several samples before departing back for Earth. As it swept by planet Earth, the spacecraft sample return capsule was released, parachuting down to a safe landing in the Woomera rocket range in the Australian outback in December 2020. Laboratory tests of the samples are showing carbon dioxide-bearing water in an iron-nickel sulfide crystal, indicating the parent body formed in the cooler outer solar system, somewhere beyond the snow line. The Hayabusa 2 spacecraft sampled the rugged rock-strewn surface of Ryugu twice, once on February 21, 2019, then again on July the 11th the same year. The first sampled an undisturbed part of the asteroid's surface, while the second sampled the regolith excavated by an impactor fired into the asteroid earlier in the mission. Once the samples arrived back on Earth and were safely taken to laboratories, scientists were able to examine them in detail, providing insights into the asteroid's evolution over time. The goal of these initial studies is to understand and characterize Ryugu's formation history. You see, while the orbital data identified the presence of phyllosilicates, it was analysis of the samples in the laboratory which gave scientists information on the detailed mineral composition and physical properties of the regolith grains. Numerical simulations based on these results show that Ryugu's parent body formed approximately 2 million years after the birth of the solar system, and it formed somewhere beyond the snow line, the distance in our solar system from the Sun, where it's cold enough for water to condense directly into a solid form rather than a liquid. The mineralogy and petrology of the samples indicate the parent body formed in the region of the early solar system where water and carbon dioxide both exist as solids. And that's some 3 to 4 times further away from the Sun than the Earth is, and possibly beyond the orbit of Jupiter. This was followed some time later by the scattering inwards of the asteroid to the current positions of the Paulana and Eulalia asteroid families, which are about 2.5 times the distance the Earth is from the Sun. The Paulana and Eulalia asteroid families are the potential parent families of Ryugu, based on orbital dynamical calculations of Ryugu's origin. It seems Ryugu's parent body would have been broken apart by some large-scale impact, which formed either the Eulalia or Paulana asteroid families, including Ryugu, which then later migrated further inwards to its current orbit. Using the physical properties measured from the samples, models of the collision suggest that Ryugu must have formed from materials a long way from the actual impact site. the lack of shock features in the mineralogy, and a temperature which is consistent with the interlayer water found in Ryugu's sapphonite, which is a type of clay mineral, are consistent with Ryugu's formation from fragments which have been excavated from areas far from the impact site. In fact, Ryugu's composition, mineralogy and chemistry all indicate that Ryugu was formed from fragments excavated from different depths of its parent body. In other words, Ryugu is composed of ejecta. It's being able to directly study the samples of the asteroid in the laboratory which has allowed scientists to reach these detailed conclusions. See, scientists get bits of asteroid all the time, but that's in the form of meteorites, the remains of an asteroid or meteor once it's reached the Earth's surface. The problem is, for most meteorites, the exact parent body is unknown. But the Ryugu sample return mission has allowed scientists to connect the dots. We can now say the mineralogy of Ryugu samples are similar to Ci chondrites, carbon-rich meteorites collected on Earth. So, understanding the formation history of Ryugu has real implications for understanding the origin of these meteorites and where their parent bodies would have formed in the solar system. This is Space-Time. Still to come, physicists say there's strong evidence for the existence of a new form of matter, and later in the science report, a new timeline for the destruction of the fabled city of Atlantis. All that and more still to come on Space-Time. Theorists have shown that recent experimental results from the Large Hadron Collider at CERN are giving strong evidence for what they claim is a new form of matter. The findings, reported in the journal Physical Review D, examined a heavy particle called a lambda b, which decays into lighter particles, including the familiar proton and the fabled J-psi meson, otherwise known as a scion. It's a flavor-neutral meson first discovered in 1974, consisting of a charm quark and a charm antiquark. The study's authors, Tim Burns from Swansea University and Eric Swanson from the University of Pittsburgh, argue that this data can only be understood if this new type of matter actually exists. See, most of the observable mass in the universe comes from particles called quarks. There are 6 types of quarks, and each has their own antimatter counterpart. It's quarks which combine to form the familiar protons and neutrons and the bevy of other particles that make up matter in our universe and which interact far more strongly than electrons or neutrinos. Now, collectively, these strongly interacting particles are referred to as hadrons, and they're described in a theory known as quantum chromodynamics. Now, even though the theory of quantum chromodynamics is now reaching its 50th birthday, it remains notoriously difficult for scientists to discern its inner workings. Swanson describes quantum chromodynamics as the problem child of the standard model of particle physics, the foundation stone of science's understanding of the universe. In fact, learning what quantum chromodynamics says about hadrons requires running the world's fastest computers for years, making it difficult to answer the dozens of questions this single experiment raises. For this reason, doing experiments with hadrons and then correctly interpreting the results is vital to science's understanding of quantum chromodynamics. Until recently, all hadrons could be understood as combinations of a quark and an antiquark like the J-psi, or combinations of 3 quarks, as seen in protons. It had long been suspected that other quark combinations were possible, and these amount to what we now refer to as new forms of matter. There'd been hints for years, but then in 2004 came the discovery of a particle called the X3872, which seemed to be a combination of 2 quarks and 2 antiquarks. A number of other candidate novelties, which we've reported about here on Space-Time, have come along since, but none of them have been definitively identified as exotic new combinations of quarks. That requires a 5 sigma ironclad guarantee. This new work combines the CERN data with other experiments in 2018 and 2019 to arrive at a consistent explanation for all the findings. Burns says the model explains the data beautifully and for the first time incorporates all the experimental constraints. And for the explanation to work, it requires the existence of several new particles called pentaquarks that would each be made up of 4 quarks and an antiquark. The research also indicates that pentaquarks are just at the threshold of being observed in other laboratories. Burns says there really is no other way to interpret the data effectively. Pentaquark states must exist. This conclusion, of course, raises the possibility that other pentaquarks are possible, and that a whole new class of matter is at the cusp of being discovered. And that is exciting. Who said there would be no new physics after the Higgs? History's been made at the Vandenberg Space Force Base in California, with the last ever launch of a Delta IV Heavy from the Golden State. The massive 71-metre-tall United Launch Alliance heavy lift rocket, complete with 3 core stages mounted side by side, blasted off from Vandenberg Space Launch Complex 6, carrying the highly classified NROL-91 payload for the United States National Reconnaissance Office, the highly secretive agency responsible for America's spy satellites.
This is Delta Mission Control. We remain in the planned hold as launch preparations continue. In a few moments, Launch Conductor Scott Barney will poll the launch team for the final go to pick up the count. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Space Force Western Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
Status check to proceed with terminal count. First stage systems, propulsion. Go. Hydraulics. Go. Locks. Go. LH2. Go. Second stage systems, locks.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operation support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC, verified T0 is set for 22:25:30 Zulu.
Verified.
Establish swing arm lock pins pull.
Active.
Polling is complete. The ULA launch team and the NRO mission director are go for launch. Until launch, you will be hearing Scott Barney guiding the team through the final steps in the countdown procedure. Several critical activities occur in the final minutes before launch, including verifying fuel tank levels and pressures in the port, center, and starboard boosters, and the DCSS, as well as arming the flight termination system. At T-minus 15 seconds, the launch table HBOs are ignited at the base of the vehicle to burn off excess hydrogen. At T-minus 7 seconds, the starboard CBC engine is ignited. At T-minus 5 seconds, the port and center CBC engines are ignited. Then, after the Delta IV Heavy liftoff, you'll begin hearing flight commentator Rob Kesselman providing launch vehicle ascent data. This is Delta Mission Control. The countdown clock has resumed, and we are go for launch at 3:25 and 30 seconds Pacific. With liftoff approaching, we're going to raise the volume on our launch team so you can hear the final preps taking place.
FPS internal. CBC locks at flight pressure and flight level.
CBC LH2 at flight pressure and flight level.
Hydraulic pressure at 4,000.
Launch sequencer start. FTS launch enabled.
FTS armed.
The launch vehicle, payload, ground systems, and Western Range are go for launch.
FTS count started.
Engine start box, go.
1 minute.
Rock, report range status.
Rock range green.
Roger.
Second stage LH2 secure at flight level.
Status check.
Go Delta.
Go NROL 91.
Trophy ignition. 10.
Tisser start.
T-minus 10, 9, 8, 7, 6, 5, 4. We have ignition. 2, 1,
Liftoff.
and liftoff of the last West Coast United Launch
Engine
Alliance
cooling water
Delta IV Heavy rocket carrying NROL 91 for the National Reconnaissance Office.
Vehicle has now begun the pitchover maneuver. All 3 RS-68 engines look good at this time. Core booster is now throttling down to the partial thrust level, and that core booster
You're
has now
hearing the
reached
voice
the
of
desired
Rob
partial
Kesselman
thrust
providing launch vehicle ascent data.
level. Parameters continue to look good. Vehicle is now 3 miles in altitude, 5 miles downrange distance, traveling at a velocity of 1,000 miles per hour. Engine parameters continue to look good at this time. Vehicle is now passing through max Q, maximum dynamic pressure. Mach 1. Delta IV is now supersonic. Port, starboard, and center RS-68 engine parameters are within the expected operating parameters right now. The second stage reaction control system pressurization valve has opened. Delta IV now 130 seconds into flight, flying at an altitude of 19 miles, downrange distance of 14 miles. Delta IV has gone closed loop guidance. Vehicle body rates are as expected. 3 minutes remaining in the booster phase of flight. Delta IV rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of almost 5,000 pounds per second. 1 minute until port and starboard booster engine cutoff, and all 3 RS-68 engines are showing good performance at this time. Vehicle body rates are near zero. 30 seconds remaining now until the port and starboard booster engines cut off. Strap-on boosters are now throttling down to the partial thrust level. Engine response looks good. We've had strap-on booster cutoff and strap-on separation. The center core RS-68A is now throttling back up to the high power level. The upper stage lock system has begun the boost phase chill down sequence to begin thermal conditioning of the RL-10 engine. 1 minute remaining in the booster phase of flight. And now the upper stage fuel system has begun the boost phase chill down sequence. Core engine chamber pressure continues to look good at this time. Core booster is now throttling down in preparation for BECO. And we have BECO booster engine cutoff. And we have stage separation, successful separation of the first and second stages. We're seeing the nozzle deployment begin on the upper stage engine, and we have ignition on the DCSS.
This is Delta Mission Control at T plus 6 minutes and 30 seconds. We just heard flight commentator Rob Kesselman confirm the successful completion of the early phase of today's flight, and all systems continue to operate nominally.
NROL 91 is likely to be part of the Keyhole 11 constellation. It was placed into a 364 by 414 kilometre high orbit. In their simplest terms, keyholes are spy satellites based on the same design as the Hubble Space Telescope, or more accurately, the Hubble Space Telescope was based on the keyhole design. The big difference is keyholes look down towards the Earth's surface rather than out into the cosmos. This mission marked the 14th launch of a Delta IV Heavy, which first flew back in 2004. NROL 91 was also the 10th Delta IV launch from Vandenberg and the 5th and final Delta IV Heavy variant to fly from the base, effectively closing a chapter in history that began on the Western Range back in 2006. The United Launch Alliance is phasing out both its Delta IV and Atlas V launch vehicles, replacing them with the new Vulcan Centaur. There are just 2 more Delta IV Heavy missions remaining on the manifest, and both of those will launch from Cape Canaveral, one next year and the other in 2024. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that blood samples from patients with long COVID who are still suffering from fatigue and shortness of breath after a year are showing signs of autoimmune disease. The findings, reported in the European Respiratory Journal, is based on data from 106 people who have been diagnosed with COVID-19, as well as 22 healthy volunteers and 34 people who had experienced a non-COVID respiratory infection. At time intervals of 3, 6 and 12 months after COVID-19 recovery, participants were asked if they had been suffering from any long COVID symptoms, and blood samples were taken to look for antibodies known to contribute to autoimmune diseases. Nearly 80% of COVID-19 patients had 2 or more of these antibodies 3 and 6 months after infection, but this fell to 41% after about a year. Most of the healthy volunteers had none of these antibodies in their blood, and in those who had non-COVID respiratory infection, levels of these antibodies were low. However, the team found that 2 specific antibodies, along with other proteins that cause inflammation, persisted in around 30% of COVID patients a year after infection. So far, almost 6.9 million people have been killed by the COVID-19 coronavirus since it was first detected around China's Wuhan Institute of Virology around September 2019. However, the World Health Organization believes the true death toll is over 15 million, with almost 620 million confirmed cases globally. Meanwhile, the Lancet Commission, a panel of world-leading experts in policy and disease management, estimate nearly 18 million people have now died from COVID-19. A new study has found that over 3/4 of the plastic mass in the North Pacific garbage patch originates from fishing activities, and the vast majority comes from just 5 industrialized fishing nations, those being Japan, China, South Korea, the United States, and Taiwan. The results, reported in the journal Nature, comes from a recent analysis of hard plastic debris found in the patch. It shows the massive amount of plastic nets and ropes likely comes from the same origins. The authors of the study say their findings show that plastic debris from fisheries are 10 times more likely to reach the North Pacific garbage patch than plastics from river sources, which tend to wash ashore or sink into coastal waters. The findings highlight the need for international cooperation and regulations in order to reduce plastic emissions from fishing industries worldwide. Archaeologists using new computer statistical analysis techniques may well have narrowed down the long-disputed time range for one of the largest volcanic eruptions in the Holocene epoch. The eruption on the Greek island of Santorini, traditionally known as Thera, is considered a pivotal event in the prehistory of the Aegean and Eastern Mediterranean region. Many scholars believe it's the most likely source for Plato's 360 BCE story of Atlantis. Although the phrase beyond the Pillars of Hercules, which is thought to refer to the Rock of Gibraltar, remains a key sticking point. Now, a report in the journal PLOS ONE has zeroed in on a narrow range of dates for the eruption at Santorini, ranging from either around 1609 to 1560 BCE with a 95.4% probability, or between 1606 and 1589 BCE with a 68.3% probability. Archaeologists in the early 20th century theorized the volcano erupted around 1500 BCE during the Egyptian New Kingdom period and created a history around this assumption. But beginning in the 1970s, advances in radiocarbon dating began to throw that timeline into chaos. The new timeline synchronizes the civilizations of the Eastern Mediterranean while also ruling out several ancillary theories, such as the idea that the Thera eruption could have been responsible for the destruction of Minoan palaces on the coast of Crete, which was first proposed by archaeologists in 1939. Well, they've been keeping a low profile for a while now, but it appears flat earthers are back. Polls by YouGov America and Fairleigh-Dixon University suggest that as many as 11% of Americans really do believe the Earth is flat, or at least that it might be. So, after being repeatedly proven wrong both by scientific evidence and observational methods, flat earthers are now developing new ways to try and persuade people. They're now claiming to be free thinkers, wise individuals who distrust the experts and their so-called book knowledge and nonsense maths, things lay people can't understand anyway. Flat earthers are now seeing themselves as the visionaries and possessors of a greater knowledge. It's an interesting new tactic, and scientists are now studying it to understand how they make their arguments and engage their audience. Tim Mendham from Australian Skeptics says this in turn will help researchers better understand how disinformation is able to spread so quickly online.
For a start, I can't understand flat earth. I don't get it.
That's because it's all a NASA conspiracy.
Oh, yes, I know. But, therefore, it's totally created. No one ever believed the Earth was flat. All the stories about, Columbus worried about falling off the end. No one did. Everyone knew it was round, right? Anyone sort of with any sort of modicum of sophistication or education or anything, the ancient Greeks knew it was round. So anyone who says, they used to believe the Earth was flat, they didn't. So suddenly you get these people who they've cropped up at various times in history who say the Earth is flat, and you try and look at the evidence, and it's pathetic, but and you try and find out why. Why do you want the Earth to be flat? And it just seems a very strange belief, totally out of the blue. Anyway, the thing is that, therefore, the reasons and the methods that flat earthers use open them up to general conspiracy theories, because, as you say, it's a mass conspiracy being put on by governments and things to convince you that the Earth is round. Why the governments would want to convince you that it's round instead of flat, I don't know. But basically, to say, as long as you can say it's a conspiracy, therefore, and you are a believer in the thing that the conspiracy is trying to convince you of, therefore you are a free thinker, and you are sort of out there, one of the radicals, I'm out there fighting with the people against the evil powers of big geography.
It's the story big geography don't want you to know.
It's strange. It really is a belief that I can't fathom, understand. Perhaps it's fun, but they have meetings, they have conventions of flat earthers, and I know people who have been to those, who are skeptics who have been along to those, and they say these people are very sincere, and they're not completely stupid, right? They have a lot of theories, and they stick by the theories. If you spend more than 5 minutes probably on the theories, you'll end up seeing through them or seeing around them, perhaps even. One stage, the flat earthers didn't believe Australia existed. They said it couldn't because it just didn't fit in with the protocols. So they also certainly didn't believe you could fly direct from South America to Australia because they're supposed to be on the other side of the world. It would take too long. Anyway, so basically the attitude the flat earthers have to themselves and to their practices and their reasons of believing in flat earth leaves it wide open to spread general conspiracy theories because it's much the same attitude. I'm not going to listen to the governments or vested interests, round earthers. I'm out there with the people. I'm fighting against mind control and I'm a free thinker. So it's flattering to the people who believe these things in the same way it's flattering to conspiracy theorists. Some conspiracies are real. I don't think flat earth is real. Has any substance to it at all. Falls as flat as a pancake, doesn't it?
Well, I know flat earth isn't real because if it was, my cat would have pushed everything off the edge by now.
That's what everyone says, yes. It's a wall of ice around it. It's sort of like Game of Thrones, right? There's a big wall of ice all the way around the outside so you can't push things off.
I've never watched Game of Thrones.
Haven't you? Well, there we are.
Ever.
Never. Okay.
That's Tim Mindham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.